Engineers are not CAD operators. Engineers are decision-making people. The human curiosity, ingenuity, and the creativity in last 2 decades took the backseat. 70% of the cost for the product is influenced by the decisions that are made in the design phase. We are here today as a cognitive design systems to transform the engineering into cognitive creation, and that's what we are building today with my team. If you don't feel the pain, you won't get the good ideas to solve them.
So, what was the initial idea? How did you decide there's an actual pain in the market that you want to solve with software?
It's not helping to innovate. In order to do that, we needed to change drastically how we design the product.
All right, ladies and gentlemen, today I have a very special guest, and we'll talk about engineering reimagined, the future with cognitive design systems. And what is actually the hook or the topic of the podcast? So imagine you can generate optimized, manufacturable designs in minutes and not weeks, and that's exactly what cognitive design systems is doing for engineers across aerospace, automotive, and defense. And I'm really glad to have Rhushik today on the show. We'll know each other for quite some time, but now today I have you on the podcast. So I'm really, really happy to have you on the show.
Thank you, Yusuf. It's a great to be here and excited to talk about the future.
Yeah,
Thank you again.
definitely. Yeah, to get started, maybe give the audience a little bit of a background. Where do you come from? What did you study, and how did you come up with the idea of building CDS?
Yeah, sure. Yeah, I mean, I'm Rhushik. I'm one of the co-founder and CEO of Cognitive Design Systems. I'm a mechanical engineer by training, and as a mechanical engineer and mechanical designer, there are two things which were frustrating me. So first of all, is the it was frustrating to work with the CAD technologies developed 30 years ago to solve the next 30 years challenges, so which was not making sense for me. And the second one is that 70% of the cost for the product is influenced by the decisions that are made in the design phase. And these two things were very important for me, and to tackle that. As a design engineer, what I wanted was to automate a lot of those tedious tasks. But I also, when working in Japan for almost 10 years, working with large organizations like Toyota and Mitsubishi, we quickly understood that the major bottlenecks that they had with the existing new product development processes was the iterative design cycle, technological silos that they have internally, and the lack of agility in the CAD environment. And we are here today as a cognitive design systems to transform the engineering into cognitive creation, and that's what we are building today with my team.
Yeah, Rhushik, you just mentioned something very important, which is you actually worked in the industry or with people in the industry. So you actually detected a problem first and then decided to build a product on top of it. And what I see in the startup space quite a lot is people think they build a solution that solves a pain or alleviates a pain, but it's actually not the case. So you actually come from experience. So what was the initial idea? How did you decide that there's an actual pain in the market that you want to solve with software?
So yeah, I mean that's a very intriguing question, because yeah, if you don't feel the pain, you won't get the good ideas to solve them, and that's what we saw it while working with the automotive giants like Toyota. When they mapped out the whole entire end-to-end design process, and we saw the all the gaps that there were between each design software, how they were communicating with each other, and the frustration that engineers had, because not everything is in their hands. They work in silos between design team, manufacturing team, simulation team, and this all is not helping to innovate in a way. And in order to do that, we needed to change drastically how we design the product. And in order to design the product better, we have to bring a lot of the insights, which usually comes very at the end of the whole cycle, to the very front of the cycle, like manufacturability, like cost, like carbon footprint assessment. All these insights needs to be taken care at very beginning, and for that, we didn't find the right technology to do it. And another problem was the CAD bottleneck. Like The designs cannot be generated. We cannot iterate faster because it was very hard to modify the designs. And we are trying to solve this problem, and we are pretty good at it at the moment.
I would be quite interested from an entrepreneurial point of view. How hard was it to actually convince the stakeholders? Because I mean, you're helping them to adopt a new technology or software piece, right, or software solution.
Yeah.
I mean, I think the initial problem of these big organizations is usually they know they have to change, but they don't want to change because they think never change a running system because something could break, something could be, turn out to be the wrong decision. So how did you actually convince the stakeholders to try it with you guys?
Yeah, I mean, and for that thing, I was lucky enough to work with the large organizations, bringing from starting from the concept design till the qualification of the component for aerospace industry.
Mhm.
So all this, the whole change, I saw the step by step process of all this, and when we showed them that, okay, look, these are the things which are missing, and these are the things could be automated. And if you are able to bring those insights, which you are usually taking care of the very end of it, very beginning, it would be much easier. We did engineering projects with them to start with, a lot of them. We did more than 200 different projects, various across with shared between all my team, engineering team, and that is the key to get the connectivity also human to human with our counterparts in the large organizations to explain them that, okay, look, this is the pain point. I am understanding you. We have experience of doing it, and look, now we are solving it. You should try it out, and it's much easier to bring it to them if you show them that you understand their pain point.
Yeah, absolutely. Let's talk about CDS itself, the platform itself. So, how do you actually then alleviate the pain using, or when engineers use CDS, your software?
Sure. So, first of all, I can maybe talk about a few challenges that the engineers actually faced.
Yeah.
So, the first of all was the manufacturability and business feasibility of the engineers, sorry, the parts that engineers were designing were evaluated too late in the engineering process, and they pay heavy price for that.
Mhm.
Large organizations, they also work in silos. So they, as I mentioned, like design organization, simulation, manufacturing, etc. And they have a very fragmented software ecosystem with that. So that was also another point that was frustrating. And then there was the lack of agility in the software suites that they currently were using. There was a difficulty in identification of the best trade-off because you don't have enough insights on the
Mhm.
part. That was a problem with the frequent system level changes, which happens at very high level, and then it comes down, to the part design side, and they have to restart again the whole thing. And the current software's inability to create and reuse also the complex engineering workflow, which is basically the engineering know-how of the organization. So all these were the key pain points that we analyzed, and based on that, we created an automated concurrent engineering platform. So what is concurrent engineering? It's nothing that I invented. It's something that was invented back in the days, and that's largely used by European Space Agency. It's a methodology where multidisciplinary team collaborates in a closed loop environment to accelerate the product development. And this concept, it resonates with me. It resonates with a lot of engineers, even in other industry that I talk to them. And that's what we are bringing, where the whole workflow is parametric, transparent, and reusable. As it's a reusable parametric workflow, we will save time and money by doing this. And on top of it, we implement various different AI algorithms for design optimization and workflow creations to help reach those goals. So that's our
I see.
current solution.
I see. To make it more concrete, let's cover a couple of talking points. So you talked about generative design, topology optimization, etc. So what concretely can we do with your software? Like, especially from an engineering point of view, I think it would be interesting to maybe walk us through a couple of examples and then how we could use the
Sure.
software in different environments or scenarios.
Yeah, sure. Yeah. So currently in our software, we are able to do various different generative design algorithms. So one of them is topology optimization. But we saw that topology optimization, which is great, but it has some it was missing out on a few things, which was it's an iterative process in a kind of a black box approach. So user loses its ability to modify and fine tune the design. And for that purpose, we developed another algorithm called topology weaving, which is we connect functional regions by structural pathways, and user have full control over the pathways on the section, on the, if it's a tube, it's a surface, etc. And it can create the workflow much easily parametrically, and we can combine it with the simulation and manufacturing optimization to evolve it into a manufacturable product. So that's a new generative algorithm design algorithm that we developed. And there is a third one that we developed, which is a topology enclosure, which is another missing point from the topology optimization was to create designs which are watertight. Some of the designs that we generate with topology optimization, it's very organic, it's beautiful, there are a lot of holes everywhere, but it's not suitable for if we have an application like housings, enclosures, other things like that, or packagings. So for that, we created an algorithm where the functional regions are connected between them with a uniform thickness surface, and then you can apply various different stiffening elements or manufacturing elements to improve it further on. So that's what we did.
Yeah, let me just, maybe it's a redundant question, but let me help to understand it, which is maybe we have the generative design part, which is maybe in the beginning of the simulation, like you have the CAD part, then you do the simulation, and then once the simulation has been done, we then test for manufacturability. Is this kind of the three-step process that you were talking about?
Yes, exactly. So we start with the generative design algorithms. Then
Yes.
we do the FE analysis on top of it.
Yeah.
Once we do the FE analysis, we can do simulation driven design to improve it furthermore by for fine tuning the geometry. We can also do manufacturing driven design to assess first of all the manufacturability of the component, and then optimize the geometry for manufacturability. It could be done in a closed loop environment, so it's much faster. You have the full control over it. And at the end, you can do the cost and carbon footprint analysis. All this together could be packaged into a one single component and send it to our design exploration tool. And that's something exciting that is coming up in very close,
Yeah,
in
yeah,
very soon to our
very cool.
software.
When we want to delve into the three-step process a little bit more so that people understand how they could potentially use it, and maybe some of the people listening to this podcast want to reach out to you. So for manufacturability or for simulation, sorry, we talked about FEA analysis, but you use a mesh-free approach. Is that correct?
Yes, we use a mesh-free approach, which is provided by our partner Intact Solutions.
Hmm.
They developed this mesh-free approach. I think they were on your podcast at some point. We use that because we are using implicit modeling as our geometry kernel, which is perfectly compatible with the immerse method of moment that they are using it. So for that purpose, we are able to do the simulation much faster, even on very complex geometries inside our software.
I see. And then when we have the third part, which is manufacturing-driven design, what can we test for? What kind of manufacturing methods?
Yeah, great question. So currently we can do analysis and optimization for die casting, molding, machining, additive manufacturing, and forging. These are the manufacturing processes that are covered by the software.
I see. Okay. Then we have the three-step process, and then you mentioned the design explorer. What will this design explorer be capable to do?
So Design Explorer, it's the new novelty that we are bringing to the product. It's a breakthrough capability that evaluates every design variation, not only for performance, but also for manufacturability, cost, and carbon footprint. It will create the graphs and reports which are automated,
Hmm.
and you will be able to filter out the right component that is suited for you very easily, and that is done in minutes instead of hours.
It's really cool. So engineers could just use a software in action that could test designs, manufacturability constraints, do FEA simulations in literally minutes, I would assume, rather than just hours or weeks, right?
Weeks are, yeah, exactly, yeah. So it's a very fast software where you can create various different components between them, and when you're connecting with those components you create an algorithm. This algorithm could be reused, of course, but this could create one iteration of your part. This iteration could be saved in the design exploration as one iteration. You can always come back to it very easily, and you'll be able to list all the iterations, filter it out. It helps you take informed design decisions, and that is very key point for us, because engineers are not CAD operators. Engineers are decision making people, and
Mm.
I want to bring the decision making process to the engineering level, and that's what we are doing with the design exploration.
Yeah, I think it's beautifully explained, Rhushik, because I think this is exactly the point I'm always trying to make. So I think the synergy between AI, whatever that AI behind the scenes does, right, and the synergy of AI plus human, I think brings the best out of both worlds, so to speak.
Exactly, yeah. Because engineers want to know also how it was done. So it's a great point about AI. AI, it's great. I mean, but if it's a black box AI, I'm not a great fan personally. I prefer that the AI has to be transparent. It has to be parametric. So we are able to go back to the decisions that AI has made to achieve certain goal, and engineers should be able to fine tune it, to take control over it, or to own it, is very important.
Would you call what you have as a solution a white box or a gray box? So will the decisions that the algorithm is making inform the engineer why it has made the specific decision and not another decision, for example? Like, can we see it as engineers?
Sorry, can you ask once more the
Yeah, about
question? I
the
didn't
AI
get
question,
it.
we talked about the black box approach, right? I think then, on
Yeah,
the other hand, your solution would be more like a white or gray box approach, where the engineers would be able to see why the algorithm has made a specific decision, right?
yeah.
Somehow.
So yeah, I mean, that's the whole point, that AI is there are two kind of AI. There is the AI in engineering software specifically. There are like maybe there are more, but there are two that are more mainly available. The surrogate model based engineering, and then there is the agentic AI that we have also with various different solvers. Both are great, but importance is on the transparency in the engineering workflow. Yeah, it's great to accelerate tasks, but if we must make sure that engineers can reuse those workflows and fine tune them and take the ownership of it, that's the best. And that's why I don't believe in black box AI. I prefer to stay a clear box or white box or gray box, as you call it.
Yeah, yeah, definitely. How will it actually impact then engineers as human beings? So, for example, we know everybody in marketing, especially when it comes to engineering, talks about reduced time to market, faster iterations, better decision making, right? But what is the actual impact you do, for example, across different departments? Maybe you guys help also in terms of communication, right? Because people can just access the workflows and see what's happening in real time. Like, what is the actual benefit there when it comes to the communication bit?
Of course. So on the communication side, the whole reporting, whole visibility over the workflow is also very important. In a CAD environment, we have the construction tree, but we don't see how it was created, obviously. If something is much more visible on your side, where you can see that, okay, this is the process that has been done to achieve a certain goal, that's much easier to understand. Also to onboard new users. That's what we see, that our users who are younger it's very easy for them to take over the software and use it. And on the communication side, we will be able to create the reports and analysis of those decisions that has been made. You can also specifically note the design intent inside the engineering workflow. So you'll be able to share your design intent with your colleagues, with your team, or with your boss much easily. and this is very important to note down.
Yeah. I mean, we talked a little bit about the benefits, or a lot about the benefits actually. What are some of the most common results your clients see when they're using your software?
Yeah, let's talk about. I mean, so maybe I can talk to you about a lot of different customer, but the first one that comes to my mind is Thales Alenia Space. They were developing 80 different configurations of satellite antenna brackets. It's a tripod-like structure that varied by functional region and applied loads. Traditionally, that would mean manually creating and validating 80 different separate CAD models. It's a slow and error-prone process. It could take tens of weeks, or if not hundreds of weeks, to achieve those 80 different CAD models, which are ready to go in the production. With cognitive design, they were able to generate, adapt, and validate all 80 configurations automatically. So we created, first of all, the one single workflow where we input the functional region, and we brought out the end part, which is manufacturable. It took us 2 days to fine tune it and create perfectly well. And after that, each iteration was in minutes to create. The whole cycle time drops from weeks to hours. Geometry bottlenecks disappear. Design iteration becomes near instant, and engineering teams shift from reactive to creative. So that's the thing that we see more and more in our customer base. We have such examples also with Safran, with Liebherr Aerospace, with T4I, with Leonardo, Mitsubishi Electrics, MBDA, etc. And they also saw that, okay, this is the power of using parametric, transparent, generative design software. By the way, I will be talking about, not me, but yeah, my colleague will be talking about it in the webinar, which is coming next week, 6th of November, and I warmly invite all of you to join it.
Definitely. We'll put the link for that webinar down in the description. I want to talk to you a
Thanks.
little bit more about the topic of AI. I mean, a lot of people, especially in the startup space, talk about AI. I believe you have AI. Can you maybe explain, of course, not giving away the secret sauce, like what is the AI actually capable to do, and how is it helping the engineers to make better decisions?
So AI is on our software. We started developing AI algorithms back in 2021. So at that time, we were not talking about LLMs and everything. We were
Mm.
more talking about some more basic AI, I would say, or machine learning algorithms. So our some of our algorithms for cost analysis, for to get the insights out of the part regarding manufacturing and the cost is uses AI to do it. But on secondary note, we also develop AI for feature recognitions, for other geometric operations and analysis, to convert the mesh models into a CAD model. So that's something that is huge on our side. We want to convert all the mesh into a reusable CAD model with the feature recognition, which allows you to do it much better. So these are the two things that we are using. We have also many other AI development going on in house, but I cannot mention. But what I have to mention is that AI should be able to help engineers create new workflows easily, because creating a workflow, that's not where the added value of the engineer is. That's a common task. Finding the right workflow suitable for your specific path would be also used using AI. And I believe that in the future, in general, AI would be as a great co-pilot for the engineer to take the best decisions for the path to come, rather than pushing on buttons here and there to make it happen.
I see. Yeah, that makes sense. You mentioned something earlier in the podcast, which is this implicit geometry engine, right? I think it would be very interesting
Yeah.
for people listening to this podcast. Why is this implicit geometry engine so important? And why is it revolutionary? Like, what is the difference between? this engine and other engines that engineers use?
So yeah, I talked about implicit modeling. That's one of the newer way of creating the geometry. I'm sure your audience is very savvy and they all know about it. But it's a mathematical representation of the 3D geometry, which allows to have near instantly all the geometry operations. It's super robust compared to the BREP or mesh geometries, which in its way of the representation, but also the modification of the geometry. This the size of the file itself is much lower, which allows us also to do the iterations much faster, in and the data processing much faster. And at the end, the implicit modeling itself is as it's mathematically driven, it's much easier to connect also with the AI algorithms. So that's a great point to put forward for implicit modeling. It has its own downsides that we have to mention. Implicit modeling is great for certain tasks like creating complex structures, and creating and modifying those structures very quickly. But implicit modeling needs a representation which is much more accurate. So we always need to convert it back to the CAD. And at that time, we have this issue of conversions where the geometries becomes more rounded or not enough accurate. And this is due to the algorithms of the conversions. So this is something that will change in the future. We are working on it also, but yeah, this is something that has been the downside of the implicit modeling.
I see. Talking about the future, Rhushik, I would be very interested, maybe before we wrap up the podcast, how do you see the future when it comes to engineering tools, in particular CDS, in the next 5 to 10 years? I mean, you talked about agentic workflows, right? Do you think there will be a big change happening for the engineers in the space? What is your vision?
Yeah, agentic workflows, they are a year old or 2 years old. So we don't even know the real potential of it. I'm sure it's gonna be a huge transformation on how engineers are designing. Engineers will move away from becoming the card operators or the pushing the buttons here and there. They will convert into somebody who is more a decision maker, like I mentioned earlier. And I also believe that the newer generation of engineers who have grown with with the video games, with the AI from their youngest age, they will not see the new product development process the same way as me or my ancestors used to see it. So the change that has happened between going from the pages with drawings that were done manually to the CAD, there will be similar or a bigger shift in the future for the new generation of engineers, and we'll be part of it. Cognitive design is working to make that future more nearer, so we can all benefit from it. And yeah, that's my take on the future of
Yeah,
cognitive design and engineering as a journey.
yeah, really great. I have one question, Rhushik, maybe a more personal one. Do you believe the job role of an engineer will drastically change in the sense of like more like a T-shaped personality versus a pie-shaped personality, right? There's always a discussion like, what do engineers need to be capable of? I mean, when I think about my dad back in the days, they had to do technical drawings by hand all the time, right? Versus then we had like 1D CAD, 2D CAD, and so on and so forth. Like, do you think that will drastically change in terms of the job descriptions for engineers in the coming 5 to 10 years, maybe 50 years?
In 50 years, it's very difficult to say because the things are moving too fast at right now. So difficult to say about the future. But yeah, in the future, definitely the job or the role of engineer in the society will be also evolving. In the past, when we didn't have the tools of the software tools, we were still creating some mind blowing products at that time. We had created, we reached the moon without having the powerful computers we have right now. So the human creation and ingenuity has no limits. Together with AI, together with the whole change of the paradigm shift that is happening, that will take the front position. I would say that will take the driver position in the coming years. The human curiosity, ingenuity, and the creativity, which, from my perspective, in last 2 decades took the backseat, and the limitations of the tools that were given to the engineers defined the role of engineer, and it will break away from it, and it will be something much bigger, much larger for the years to come.
Yeah, is that what you would you define as a cognitive engineer, or do you define it a little bit different?
Exactly, yeah. What is cognitive design? That's the whole goal, is that we want to transform the engineering into something called cognitive creation, where engineers are able to design the product based on their cognitive senses. So it becomes as easy as that, and not as painful and as much the burden that we are putting on it to create simplest designs sometimes.
I see. I'm wondering, maybe we can do a round of firing questions,
Sure.
because I would be interested in your personal opinion. What's your favorite engineering innovation of the last decade?
In the last decade, I don't know if it was last decade, it was the decade before that, but yeah, the rockets that can land back, what SpaceX has achieved, I believe that that's a crazy stuff, and that's something that I would love to wake up for, to be excited about, and looking forward for the future. That okay, if we are capable of doing that, maybe we will be capable of reaching other planets very soon, and and beyond.
Absolutely. I like the stand that you're taking. I think a very important one is, what is one misconception everybody has about not everybody, but a lot of people have about generative design?
Yeah, and I believe you have heard this also a lot of time. Generative design is not topology optimization, and topology optimization is not AI. That's also one point that has been that has to be that will be put forward. But yeah, generative design is one of the tools that allows us to create new designs at a much faster rate than before. It uses various different algorithms. It could be based on sometimes AI or machine learning. It could be analytical algorithms. It depends on how you approach it. But it creates new designs for a specific requirement easily. That's all.
If you could automate one part of your job with or without AI, what would it be?
That's a good question. I would automate the job of taking meeting notes. I think that's already has been done a lot
Yeah,
with a lot of AI tools. But yeah, I would be able to go even further to improve it. But yeah, on a more serious note, I would probably would love to see how we can go beyond the 2D drawings that we have right now, that are still required to do the manufacturing, and the MBD, the dream that has been sold on it, really becomes the reality, and we can create the 3D models in 3D.
that's great. And last but not least, one word that describes the future of design.
The one word to describe, I would say passion. That would be the one word for the design, because design is always driven by the passion of the engineer. There is always this connection between what you are creating and the engineer that creates it. Uh, and this is the passion that has motivated me to go in this field and do the new jobs, or to create new stuff. and this passion has to stay alive as an engineer, and it should not die out with because of the boredom of CAD operations.
Absolutely. And last but not least, where can people find you, and who is CDS for? I think that's also very important to mention.
Sure, yeah. So you can always find me on LinkedIn. I'm available there. You can also reach out through our website www.cognitive-design-systems.com. And next week, as I mentioned earlier, we'll be doing a webinar with Thales Alenia Space, and we welcome you there to join us, and we can take over from there on.
Yeah, I'll definitely join for sure. Thank you so much, Rhushik, for this interesting podcast. I'm sure maybe we'll have a deep dive in the future where people can actually see your software in
Sure.
action. That would be really, really cool. And yeah, thank you so much. And hopefully there will be a second part in the future. Who knows? Thank you so
Thank
much.
you. Thank you very much, Isaac.